They're like, wait a minute, what? Miraculously, we have ended back up a nice clean sheet. So, okay, let's try this again. Okay, our amplitude as we go into warm-up is my max minus my min divided by 2. Well, we're going to get there. For those of you that are just tuning into this for the first time, you don't know the inside joke of this, but you may hear of it sometime during this. So we've got a max at 10. We've got a min at negative 4. So 10 minus negative 4 divided by 2. What happens when we minus a negative? It becomes positive. So that's better. Okay, so our amplitude is going to be 7, which means from our midline, which we're about to find out, it's going to go up 7 and down 7 from there to kind of show us how big our wave or our sine function is going to be in this case. Okay, our midline is going to be those same max and min values, except we're going to add them together and then divide by 2. So 10 plus negative 4 divided by 2. So 10 minus 4 is 6. 6 divided by 2 is 3. And normally when we do a midline, we make it a y equals equation because y equals equations are horizontal lines. And the midline is a line. So 1, 2, 3. And midline is exactly what it sounds like. It's a line that goes through the middle of our function. And it's equidistant, or equal in distance, from the maximum, which is up 7, hence my amplitude, and my minimum, which is down 7.
Is there a reason why you didn't something about the darker one? Like, the midline up?
Yeah, the midline here is just telling me where on the y values, that I'm going to put that horizontal line in. And if I've done my math right, it'll always be the same distance away from the minimum and the maximum that I'm doing. It's kind of my way of checking that. And then our period, our way of calculating it before was just finding 2 spots on our graph that were an equal distance apart. So maybe I decide I'm just going to stick with the maximums. And I look and I'm going to go, well, if I say something like starts here, and I go down and I come up, and I see where that second one is, how far away are they before the pattern starts over? 1, 2, 3, 4. So my period would be 4. And again, whether you started at a couple of the minimums and said I went up and then I went down, and then I went up and then I went down, you'd get the same value. So those were the things we looked at before. But now we're still going to use those things, but we're going to use them for us to be able to make the graph. And again, this is going to take a little bit of time as we go, but it's going to be nothing that's too terribly awful to be dealing with as we finish these off. So, let me bump this up a bit. Now, here's a positive thing for you to know right off the bat, okay? This chart up here with all these things, here's where it can be helpful to you, okay? Here's where you're not going to have to worry about it. It's helpful in giving us some values when we go to graph. I'll show you how we can find them in a little bit. But you're not going to have to memorize the values that are down here from our unit circle. Okay? You'll always have those values either available or we can find them on the calculator. We'll have some way of making that easier for you when we're doing that. So, when we go to graph, and this is going to feel like review, and it kind of is, but it's going to be something we need to make sure we do this. Again, our amplitude is that distance that we looked at up in the warm-up from our midline, okay, which for us is always going to be the x-axis. We're not going to worry about up and down shifts right now. Okay, so for us, our midline's always, for the time being, going to be on the x-axis, or at y equals 0. To the highest peak, or to the lowest valley. So highest peak, lowest valley. Okay. Our new part of this is going to be a little change to how we did the period before. Okay. Before, with our period, okay, the time it takes to complete one pattern or one cycle. So if we start here and it ends here, we try to figure out what that value is going to be. Thank you. So it used to just be a number. It used to just be, you know, it's 1, it's 4, whatever the value happens to be. But now we're going to start getting some pi into this. We're going to be into radian mode. We always were changing the calculator to degrees before. Well, now we're going to start doing some radian things with this. So this one happens to go 2 pi, or 1 complete period. Okay, so let's just say one thing here. So for my normal sine function, the period equals 2 pi. That's how long it takes for it to do one whole cycle of its curving. That can change sometimes, but we're going to see how we calculate that in a minute. But if I don't see anything telling me that, that's how big it's going to be. It's going to look like this. And we can even look at it on the calculator, but we'll get to that momentarily here too. So as we flip over, and we talk a little bit about the sine function. Now there's some parts to this that are going to help us make sure our graphs are working well. Okay, if there's a value in front of the sine, a number, that's my amplitude. Okay. The amplitude will always, 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 always be positive. You're like, wait, what if it's a negative number there? It's still positive because it's a distance. That's why when we look at this, there's absolute value bars around it. Because when we take the absolute value of something, we get a positive value out. And then my period will be 2 pi, what it is normally, divided by any number that we put right in front of x. That'll split my period up. And we're going to see an easy way to do that too. So when we're asked to find the period of each sine function, I look at this and I'm like, okay, there's no value in front, but my b value is 8 in this case. So to find the period, I just take 2 pi and I divide it by 8. But as we've said before, if I can reduce the fractional part, not the pi's got to stay, we're in radians. If I can reduce that part, though, I need to. Can I reduce 2 over 8? Yeah. To 1 over 4 or pi over 4. And it's okay if you put the 1 in there. That's not a big deal. Now, the second one, this gets a little more complicated. 2 pi over 1/3. And some of you are like, yuck. I don't know. Okay, let's think about it in a little different of a way. Let's write it a little bit differently and see if that helps. 2 pi divided by 1/3. What do we do to the second fraction when we're dividing? I know, it's the day after spring break. Okay. We flip it and it turns into multiply. Oh, you did. See, my hearing's not working the first day back. So I just flip that fraction over and I multiply. And 2 pi times 3 is just 6 pi. So when I'm dividing by a fraction, okay, my value gets larger. Okay, when I divide by a value less than 1. So again, if you want to write that out, you can. If you want to look at this and say, ooh, I'm just going to multiply by the opposite, or the flip, that's A-okay too.
What you do?
All I did was I took 2 pi and divided by my b value. My b value here was 1/3. So I did 2 pi divided by 1/3. But when you divide by a fraction, when you divide by 1/3, it's the same as multiplying by the reciprocal, or the flip of that. So I just multiplied 2 pi by 3, or 3 over 1. And that's where my answer is coming from.
Okay, just making sure.
Sure, absolutely. And so then what's the amplitude of each sine function? Again, that's just going to be the value in front of a. So my amplitude is 2. Now be careful on letter B. Nice. My amplitude isn't -4, it's +4, because it's always going to be a positive value. It's distance. Okay, it's my distance from my midline. You're like, shoot, just give us a bunch of these questions. This would be simple. All right, and then we'll kind of put it together here. Find the amplitude and period for each of the following. Okay, let's do the easy part first. My amplitude is 2. Just whatever that value is in front of my sine function. Now, my b value is 4, but that's not my period. My period comes, 2 pi over 4, 2 pi over b, and then reduce the fraction down, okay, the coefficient part, again, not the pi, 1/2. Or you can write pi over 2, but if you write 1 pi over 2, that's a-okay. So you're like, okay. So the number in front of sine is my amplitude, but it's always positive. And then my period, nice. Okay, because again, if I divide by a value less than 1, a fraction like 1/2, you're really just multiplying by its reciprocal. So it's really 2 pi times 2, which is 4 pi. But again, if you need to visually see it, write it out and then flip it, that's fine. Okay, we're never going to go on a speed thing where you wouldn't have time to be able to do that. All right. So letter C, I'll let you guys do the talking here. What's my amplitude? 3. Good job. Didn't get stuck on the negative. And then what about my period? Just pi. Nice. So we've figured out our period. We've figured out our amplitude. Now we're going to use those things to actually start doing some graphs, and that's why you got the graph papers you came in today, even though we're going to do a couple of them off the homework together to make sure we're good. Okay, steps for graphing a sine function. Find the period and create a scale for the x-axis. Okay, so we got to find the period here first, so let's kind of label our stuff here. Okay, our amplitude's 2. We'll need that in a minute. My period is 2 pi over 1/4, because again, my b value is whatever number's in front of x. So what would 2 pi divided by 1/4 be? 8, because again, flip this, makes it 4. 4 times 2 is 8 pi. So you're like, okay, so create a scale for the x-axis. Well, what's that mean? Okay, I'm going to skip down to 3 for a minute to help us do this. We're going to plot 5 points for each of these. We're always going to start at 0. So if I start at 0 as one of my points, that leaves me 4 more points, okay? So 0 plus 4 more. So 1, 2, 3, 4. And whatever my period equals, that's the last line that I'm going to do. So in this case, that would be 8 pi would be my last one. That's where my period's going to end. And I'm starting at 0. Now here's how I like to do it. Everybody does this different, but I think this makes sense. I'm like, okay, let's think about this like a line. Okay, here these at. If I started working in towards the middle, okay, that's the middle. What's immediately in the middle of 0 and 8? 4. Okay, so this is 4 pi. And then I'm just going to find the middle of my other two little segments, because here, this is the middle of these two. What's between 0 and 4? 2. Yeah, and between 4 and 8 is 6. Now, is it always going to come out in nice whole numbers like this? No. But we still can use that to build it. So you're like, okay, so I've got my scale. Find the amplitude. We did. Normally what I'll do is I'll just make one line above and one line below. The positive one, of course, goes on top. Its negative value for the same number goes down below. And then I'm going to plot 5 points. Now here's where I've got to watch this. If my A value is greater than 1, okay, it is, it's 2. I start at 0. Then I go to the max. You're like, well, how do I know that? The max is just my amplitude that I go up to. So I go up to 2. Then I go back to 0. Then I go to the minimum, which means I go to the amplitude in the negative. And then I go back to 0. And I get my sine curve. Okay, sine curves will start at 0. Because you notice no matter if my A was greater than 1 or less than 1, I started at 0 either way. And I just connect the dots, and that's my cycle. And I'm set with that. Now, I want to make sure, though, this is the part that gets me a little more worried. So I'm going to go ahead. I'm going to help out with some of the questions in the book. So we're going to get you a head start here, which is always a nice thing. So I will get my book opened up here so you guys can see what's going on here. Because the assignment's on the front. So let me move this where we're going to be able to see things okay. And what we'll do is we'll hit up a problem in each of the sections together to make sure that you've got a good example for everything. So, first part, up here at the top, and I'll even put this on here so for reference later, if you're looking at something you could see this. So on 856, in this first section, it says, use the graph to the right to find the value of sine theta for each value. Now, again, don't make life complicated. So like, for instance, if I'm doing number 6, and it says, okay, I want you to find the value at pi over 2 radians. Okay, so I go to where pi over 2 is. I look at the graph. What y value am I at? 1. Now, you're like, well, what happens if it's not rated a whole number? You guesstimate as close as you can. So if it looks like it's at about a half, you say it's a half. If it looks like, I don't know, looks like about 0.75 or 3/4, just go for that, okay? But you're just guesstimating on where they're at. But most of them come out to nice numbers, okay? But that's all we're looking for in that first part. And then we work those. Now let's see here. Let me keep moving this a bit. So then we get up to like number 12. Yep, that's on the assignment. Determine the number of cycles each sine function has in the interval from 0 to 2 pi. Okay. Find the amplitude and period of each function. Okay, so here's a couple of things I notice. So I'm like 1, 2, and then my third line is pi. 1, 2, so this, I'm going to do a bad thing. I just made it out to the world. 2 pi basically says it gets me to the end of the graph. So, how many cycles is that? Well, let's see. If I start here at 0, and I'm like, okay, up and down. And this gets me back to the beginning because this would be one complete cycle. So there's 1. There's 2. There's 3. That's all I'm doing. I'm just counting how many cycles get done. Okay. That's my first part, and then it says find the amplitude and period. Okay. Well, my amplitude's pretty easy because we said on all of these, my midline is at 0. How far is it from 0 to 2? I don't think that's too tough. So my amplitude would be 2, because again, it's going to be positive. And then my period, I look to see. So I saw 3 cycles. That's going to be my B value. So B equals 3, or the number of cycles that it, whoops. So right, my period then is going to be 2 pi over 3. And if you can't reduce the fraction part anymore, that's okay. If you can, we do. But if you can't, we don't. And we just kind of work it that way. So again, nothing too bad. It's just getting used to the lingo a little bit as we're trying to do some of these. So keep moving. Now we get to the part, this is the more fun part. Okay, sketch 1 cycle of each sine curve. Assume A is positive, greater than 0. Write an equation for each graph. Now that's something we haven't done yet. So, okay. So let's hit up 15. So my amplitude is 2. My period is 2 pi over 3. So here's how we're going to do this when we go to graph it. We scooch this over a little bit. We'll kind of think back to what we did on our practice one that we did. So I'm like, okay, so my amplitude is 2. So I'll get those marked off. And then we talked before about how we're going to have 4 lines, because we're always going to start at 0 with these. So that's not something I have to think about. So once I get that 0 in there, I'm like, okay. And we talked about how when I do a period, the last line that I have marked is always going to be what I have here. Now this is where it gets interesting. Okay, we're going to forget about the pi part for a minute. What's right in the middle of 0 and 2/3? Let's make it a little easier. What's in the middle of 0 and 2? Okay, so 1 pi over 3. Now, if you weren't sure, if you were just absolutely going, I have no clue what's in the middle of those two, here's an option. What I could do is I could go, okay, well, let me get out of here first. I could say, hey, what's 2/3 divided by 2, math, enter. Okay, 1/3. And then I'd know it's 1 pi over 3. But now it gets really crazy. Because you're like, now I need to know what's between 0 and 1/3. You're like, I don't know. Okay, if I don't know, let's check it out. 1/3. Because again, I'm always doing this without the pi. Divided by 2. Math, enter. 1/6, or pi over 6. And then if I'm not sure what's between 1/3 and 2/3, now you're like, well, how do I do that? You know, because this is a little bit different. It's not, I can't say 2/3 divided by 2 because I'm just going to get 1/3 back. You're right. So I'm going to show 2 ways you can get to this. You're like, oh my gosh, Harty, you're always showing us 2 ways for everything. Okay, so I take 1/3 plus 2/3, because again, I'm looking at my endpoints, right? And then if I want to find the average, if I want to find the midpoint, I just divide that by 2. And what's 0.5 as a fraction? 1/2, or pi over 2. I'm always looking for what's that number in between. What's the average? Now here's my other way that I like to look at it, but you have to like fractions to do this. Here's how this works. Once I got this part, that's 1/6. 1/3 is 2/6. 1/2 is 3/6. So if you wanted to mess with a common denominator, you can just count right in order. I'd still reduce them down some, but you could, okay? Just an option. But if you want to do the calculator thing and just divide, that's okay. And then if I need to cheat a little bit from my note sheet, I can. If my amplitudes are all positive, I start from 0. And then I go up 0, down 0. So 0, up to my max, up to my amplitude, down to 0, down to my minimum, back to 0. And go with my big old curve. That's going to take a little practice. I think you're going to feel comfortable getting the amplitude, knowing that this value is the period, but it's getting used to that other piece of this. It can be a little bit tricky. So let's play with one more of these. I'm just looking to see. Let's go up to 17. We'll keep this one in here, and then I want to do one other weird one. So 17, I'm going to peek underneath here. My amplitude is 4. And my period is 4 pi. So again, I get that worked out. If my amplitude is 4, I get my 4 values, knowing my first one's always going to be 0. And in this case, my last one is going to be what my period is, because that's where it's going to end at 4 pi. Now I've got to figure out what those other 3 values are going to be. And again, I would just keep cutting them in half. What's between 0 and 4? 2. This time it's going to be a little easier to mess with. Between 0 and 2, 1. Between 2 and 4, 3. And again, since they told us to assume that my A value is positive every time, again, I'm going to go from 0. And when it's positive, I go up to the max, back to 0, down to the min, back to 0. Curve and curve. Okay? So my graphs will all look the same. It's just going to be the scale that I'm using is going to be a little bit different each time. And I think I've got one more on the docket here. I'm going to move this out of the way long enough that I can look. Oh, yeah. Okay. So then, if I move down a little further, it's going to say, move this up a bit. Oops, that's a little too far. Get the calculator out of the way here. What's that? No. So sketch one cycle of the graph for each sine function. Thank you. So let's try out, I want to find one that's going to be weird. Oh, that looks weird. Let's do 22. So 22 is going to be y equals sine 3 theta. Okay. You're like, ooh, what's that? So basically, here's all that that's going to do. And I'm going to move the book out of the way for a second here so we can actually write. Now this time they're not giving me the amplitude and the period. I have to find it. So I don't see a number in front here. So my amplitude is going to be 1. That's pretty easy to work with. If I don't see a number, we assume it's 1. Now, this 3 is my B value. That's not my period. My period isn't 3. My period is 2 pi divided by 3. If I could have reduced 2 over 3, I would. But if you try it, you're going to find out that you can't. So with that in mind, I'm going to do exactly what I did on the last two, on 15 and 17. I'm going to put my amplitude numbers in. I'm going to make my 4 more lines because I know my first one's going to start at 0. My amplitude is positive. So here's becomes the game now. 2 pi over 3. Now, I'm hoping at this point you're thinking to a problem up a little further on your paper to make this easier. Because again, I take this. In between 0 and 2/3 is 1/3. And I'm going to cheat a little bit because I already see on 15 it's the same numbers. But don't worry, we're going to do another one that's screwy here to get us some practice. So I get my values. And once I have them again, with a positive a value, it's up to the max, back to 0, down to the min, back to 0. And I get it drawn in. Now I want to find, let's find some weirdness. I'm trying to see which ones I gave you guys so I can find something weird. Ooh, 25 might be fun. Yeah, 25 looks like fun. So check this out. We're going to do like half this assignment together. This isn't bad. It's actually a pretty good deal. So 25, I see it. I know you guys don't. Ooh. So 4 times the sine of 1/2 theta. Okay, what's my amplitude? My amplitude is 4. My period is 2 pi divided by 1/2. Which again, we said when we divide by a fraction, it's like by multiplying by its reciprocal. So it's 2 pi times 2, which makes my period 4 pi. So again, I can label my amplitude values. If you want to count by ones, you can. I just like marking my top and bottom that way. 1, 2, 3, 4 more, because I know I'm starting at 0. I am ending at 4 pi. Again, I just work it from there. Between 0 and 4 is 2. Between 0 and 2 is 1, but if I had to, I could go to my calculator to help me. And in between 2 and 4, just like doing a midpoint formula, 2 plus 4 is 6, divided by 2 is 3. That's all I'm doing on these. I just keep finding midpoints until I get my values found. So once I have that, start at 0, no matter what. Up. Again, if my A value, if my amplitude is positive, if this would have been negative 4, I go down first and then up. But that's not what's going on here. Minimum back to 0. But again, let that little chart that's on the note sheet help you as well as we're doing that. I want to make sure I get a negative. Can I? Yes. All right. 28 is going to be our last one. They actually give me a picture to work with. So I got to replay this a little bit. Let's see here. Let's get this guy up here. Okay, 28. I want the picture available. Nice. And plenty of room. Okay, we're good. Okay, so 28. The directions say find the period of the curve, then write an equation for the function. Okay. So I look at 28. What does it look like my amplitude is? What value is my high and my low at? 3. So my amplitude is 3. And then I'm looking through again to try and see what the period is going to be. So I'm like, okay, so from 0, so if I start here, okay, I got to see how long it takes me. So here, up. Now this isn't a complete period here yet. Just because I get back to 0, the whole pattern has to repeat. So down, up. Now when do I hit down again? Here. Now the question is, where am I at? You're like, I don't know. Well, let's see. Here's 0. So 1, 2, 3 lines gets me to pi. So 1, 2, 3 more lines would get me to 2 pi. So my period is 2 pi. I'm not doing 2 pi divided by 2 pi. I'm literally looking at the graph and seeing what my period is. My period is 2 pi. So here's where the fun part starts. Because remember, they want us to make the equation this time. So we're like, ew, it's kind of weird. Now, notice, did I start, when I started my graph at 0, did I go down or up first? I went down, which means I'm going to have a negative value with my amplitude. If I go up to start, it's positive. Okay? Down to start, like we did on 28, it's going to be negative. So then, normally when I get to here, I've got to know what the b value is. Well, the b value is found by doing 2 pi divided by b. But you're like, I know the period already. The period's 2 pi. So how do I figure out this b value? Well, if you take 2 pi and divide it by what you found for the period, that's 1. That's my b value. So I can put a 1 here, or I can just put my little theta thing there. If you want to put a 1, you could. And that would be my equation once I know what my amplitude and my b value is going to be. Now again, we're going to spend tomorrow going through this again, doing more practice and working. But like I said, we've done almost half the assignment together. So if nothing else, take a quick picture of page 856 and try a couple more to reinforce it so you're feeling comfortable with this when we give it another go tomorrow.